What are shapes? Is it the defined edges that form the shape in your head? Or the negative space between them? Does a shape require color? What about its edges? What if it blends into the background? Is it still a shape then? Does it need a scale and position to be a shape? Or can its form be more abstract? I define shapes using what I call the N-shape method. Now my friend says this is not a helpful abstraction at all, and I should use a vector of points instead. But let me explain. So the N-shape method was inspired by this raylib function, which can draw nearly any shape as long as you provide it with a number of sides and some other information. But if I'm going to be honest, I had a few personal gripes with this function. So first of all, triangles are actually drawn upside down, and it draws diamonds instead of squares, as you can see here. Secondly, if you want a polygon with an outline, you have to call a separate function. And finally, and what does it in for me, is that it scales uniformly, and I wanted me some thick octagons. To solve the first couple problems, I wrote a draw shape function that will draw either a circle, a point, a line, a triangle, a rectangle, or a polygon, depending on the number of vertices provided. Then I used my patented N-shape technology to define a shape as its number of vertices, a pointer to its outline, and a pointer to its color. But I still needed some thick octagons, so I went ahead and modified raylib's drawPoly function to include a vertical and horizontal radius, as well as an origin point with 0, 0 being the center. But this introduced a new problem. You see, raylib's polygons are built to only rotate around the center, so if I want to use my own custom origin points, I would first have to learn how to rotate a point around another point. So it turns out this is actually the formula for rotating a point around the x-axis, and this is the formula for rotating a point around the y-axis. But this is with the caveat that we're rotating around the point 0, 0 specifically. I'll explain why. So here we are in Desmos, a free online graphing calculator, and I've plotted a point which I'll call P0 at 4, 5. Now this green line represents the point's x component, and this blue line represents the point's y component. And this is the distance from 0, 0. We'll call it r. As you may have noticed, we have generated ourselves a little triangle with the angle phi located here. This allows us to get a bit more specific with our x and y components for P0. I don't know if SOHCAHTOA rings any bells for you, but in trig class we learned that sine of an angle is opposite over hypotenuse, and cosine of an angle is adjacent over hypotenuse. This lets us represent our components in relation to the distance and angle from 0, 0. The x component is equal to our cos phi, and the y component our sine phi. So now let us consider P1, the point which results after rotating P0. Fundamentally, rotation does not affect length or scale, so r will remain the same distance, but the point will be located an additional theta degrees from 0, 0. So we can say the components of P1 are equal to r cos phi plus theta and r sine phi plus theta. Furthermore, we can recall the following trig identities and substitute them in to solve for P1. Now this may look like a mess, but remember, earlier we said this lets us represent our components in relation to the distance and angle from 0, 0. The x component is equal to our cos phi, and the y component our sine phi. Substituting in these values is what gives the formula I showed at the start. So in the code, we draw polygons by first checking if we're going to rotate it or not, and then determining which point we're going to draw/rotate from by applying the origin point transform. In the case we do have to rotate, we set this point to 0, 0, perform the rotation, and then translate back. And in the next episode, I'll explain what this does. So that's it. That's how we draw shapes in the No GUI framework. First we define a shape, and then we call the draw shape function. I should also mention that I created a transform class to help keep track of a shape's position, scale, origin point, angle, all that stuff. Oh, and I also wanted to hop on here to let you guys know that this series is also available over on odyssey.com. So I've honestly been overwhelmed by the amount of support we received here on YouTube. Like, you guys are seriously just too nice. But over on Odyssey, we're chilling with a cool 0 views. So if you're on that platform, I just want to let you know that I am also there. And that's all.